novel concept, we'll start with the definition of a circuit. You actually get 3 definitions for the price of 1. What all do you get defined for you? Circuit, active element, and passive element. Every single circuit, to truly be a circuit, has to have active elements, things that supply energy to the circuit, and passive elements, things that take energy from the circuit. So you have to have both, and you have to have a closed path. There has to be a way for current to flow for it to truly be a circuit. Now, how these active elements and passive elements are combined can vary all over the place. So you can have really simple circuits, and you can have not so simple circuits. But they all kind of fall into this main definition. We're going to define today 3 key terms that will follow us throughout the unit. And the first one is the term voltage. Voltage is defined to be the difference in electric potential energy, and then in parentheses I put per unit of charge between 2 points. This part in parentheses is there because to truly define the word correctly, we have to have the per unit of charge. Or what we're going to talk about right now, just to have a good understanding intuitively of voltage, we'll talk about it as a difference in energy between 2 points. But technically, what's in parentheses here has to be there. Voltage is not a great term. It's named after somebody, okay, which we love to do in science. So we love to name something after somebody, and as soon as we do, it loses meaning. The real term here that makes sense is the term potential difference. Voltage is a difference in electric potential. So the difference in electric potential energy per charge between what? 2 points. And that's really, really important. We cannot talk about the voltage of 1 point. Voltage is a difference between 2 points. So if you think about every battery you've ever seen, whether it's a watch battery or a car battery, what do they all have in common? They have a negative and positive terminal. And how are they all rated? In volts. So when they say this is a 9-volt battery or a 1.5-volt battery or a 12-volt battery, that voltage is a measurement of the difference between what 2 points? The positive and negative terminal. Because it doesn't make sense to talk about voltage at 1 point. So it's always between 2 points.
What about like something that you plug in the wall that says voltage?
What about something you plug in the wall that has voltage? What do you notice about every single plug? It's 2 prongs. Third prong is a ground prong if it has it. Okay. But it has 2 prongs, and there's a difference in potential between the 2. If there's not, nothing happens when you plug it in. So you always have a difference in potential between 2 points. The symbol that we're going to use for voltage in equations is a capital V. What do you think the base units are for voltage? Shout it all at once. Volts. Okay. It's also abbreviated with a capital V. So the symbol we'll use in equations to stand for voltage is a capital V, and the symbol we'll use to stand for units of volts is a capital V. So you have to pay attention so that you don't get things confused. If we want to define what a volt is, we have to go back to the definition of voltage. It's a difference in potential energy per charge. So how do we measure energy? What units? Joules. What does the word per mean mathematically? Per means divide. So it's the difference in energy, joules, per charge. What are the units for charge? Coulombs. So the base unit for charge is a coulomb, C-O-U-L-O-M-B. It's abbreviated with a capital C. So 1 volt is exactly equal to 1 joule per coulomb. As we get into circuits and drawing circuits and understanding what's happening, voltage is going to be key. Understanding what voltage is and how to understand it in the context of a circuit will unlock your understanding to a lot of what's going on.